This section is called Modeling with Linear Equations, which really means word problems. Yay! What's that you say? Not yay? You don't like word problems? Come on, this won't be that bad, I promise. I'll try to explain how to approach word problems, how to get a handle on them, and the ones we're actually going to be dealing with in this section are really not all that complicated. You can do this. Come on, it'll be fun. So let's start off with an example. And yeah, sometimes the examples or exercises that you see in algebra books are kind of contrived and artificial. And that's to give you practice at the process of solving word problems, of taking a situation and translating it into an equation so that you can use your powers of algebra to solve that equation and get the answer to the problem. There are real-world problems that involve algebra, but sometimes they're more complicated or require some background knowledge to really understand what's going on. So a nice artificial problem can be simpler to deal with and give us practice in our problem-solving abilities. So here's my artificial, contrived word problem example. 2 years from now, Rachel will be twice as old as she was 10 years ago. How old is she now? Okay, when faced with a word problem, a good way to get started is to first focus on what is it we're trying to find. What are we trying to find here? Well, look, there's a question. It ends with a question mark. How old is she now? So if we knew the answer to that question, that would be the solution to this problem. We just need a number for that fits the situation described in the problem. So we're trying to find how old Rachel is now. So if you're not sure where to go now or how to get started, here's a trick that can sometimes help you get a handle on what's going on with a word problem. The trick is guess what the answer is. Like I might guess, maybe she's 30. And then check and see if that guess really fits what's going on in the problem. Okay, so if she's 30, 2 years from now, she will be what age? 32. And then we're talking about 10 years ago. If she's 30 now, 10 years ago, she would have been 20. And it says 2 years from now, Rachel will be twice as old as she was 10 years ago. So is her age 2 years from now equal to twice as old as she was 10 years ago? That is this age for 2 years from now, 32, is that the same as twice her age 10 years ago? Is 32 equal to twice 20? 2 times 20? Well, no. So we were wrong. I didn't expect my guess to be correct, but now that we've gone through this, we can get a handle on what we were doing to check that guess. Whatever number we started with as our guess for how old she is now, 2 years from now, we got that by adding 2 to that number. 10 years ago, we got that by subtracting 10. And then to check whether we got this right or not, whether our guess was actually correct, we had to see whether the number we got from taking our guess plus 2 was equal to twice, that is 2 times, the number we got from our guess minus 10. That didn't work for 30, but there is a number that it does work for. That's the number we're trying to find. So we could guess again and again and again until we find something that works. But instead, let's say there is a number that works, and for now we're going to call it x. Replace the specific number we guessed with that variable x. So 2 years from now, x plus 2. 10 years ago, x minus 10. And 2 years from now, she will be twice as old as she was 10 years ago. X plus 2 equals 2 times x minus 10. Aha! There's an equation. We could solve that equation, and then we'd know what x is, and we'd have our number. So here we go. X plus 2 equals 2 times x minus 10. Remove the parentheses. X plus 2 equals 2x minus 20. Get it so that one side is just for x terms, the other side is just for constant terms. So here we can subtract x on both sides and add 20 to both sides and get 22. So looks like that's the answer. She's 22 now. So 2 years from now, she'd be 24. 10 years ago, she would have been 12. And yeah, 24 is twice as old as 12. Yay! So she's now 22 years old. Okay, now we're going to get into some problems involving percentages. So first a couple warm-ups so we know how percents work. What would you have to pay if a 7% sales tax was added to something that costs $40? If you want to pause the video and try to calculate it yourself, you can. But here's the answer. 7% means 0.07. Percent means per 100. And so to convert that to a decimal, we have to divide by 100, which is equivalent to just moving the decimal point over 2 spaces. So when you're converting percents, always move the decimal point 2 digits. And then 7% of something would be 0.07 times that thing. In this case, it's the $40 price. So we're adding on not just 0.07, that would be adding on 7 cents, but we're adding on 7% of the $40. So 0.07 times 40 is the amount of the sales tax, and that got added on to the original price. So $40 plus 0.07 times $40 comes out to $42.80, $42.80. Next warm-up example, you're currently making $20 an hour. Suppose your boss tells you he has to give you a 50% pay cut, but he'll immediately follow it up with a 60% raise. Is that okay with you? Sounds pretty good, right? You go down 50%, but then you go up 60%? Surely you'll come out ahead, right? Well, let's think this through. 50% of $20 is $10. So when you get your 50% pay cut, you're losing $10. You're going from 20 down to 20 minus 10, which is 10. Now it's time for your 60% raise. What's 60% of $10? Well, that would be $6. So when you get that $6 raise, that brings you up to $16. So you went down 50%, up 60%, and ended up below where you started. And that's because these percents were not percents of the same thing. So, moral of the story, when you're working with percents, you have to watch out for, okay, what is it a percentage of? So now, ready for a real example? If something is on sale for 35% off the original price, and the sale price is $273, what was the original price? Now here is the wrong way to do this. I see lots of people try this, but it doesn't work. You start with the sale price, $273, and add on 35% of that, 0.35 times 273. And if you do that, calculate it out, it comes to 3.6855. That's not correct because Remember what I was saying, with percentages, it matters what it's a percent of. So if something's on sale for 35% off the original price, that means 35% of the original price, not 35% of the sale price. So we shouldn't add on 35% of $273 because that's not the original price. We're saying that if you added on 35% of the original price, then that would make up the difference. So this is one where you could make a guess. You could say, okay, maybe the original price was $5. And then we subtract off 35% of $5 and see if it's $273. And if it's not, our guess was wrong, but it tells us what we have to do to the number that will turn out to be correct. The original price minus 35% of that original price has to equal the sale price, and we know what the sale price is, it's $273. So the original price is what we're trying to find. Stick it in as X for now until we figure out what that is. And it says X minus 0.35 of X, 0.35 times X, equals 2.73. Okay, there's the equation we have to solve. I'm going to start by combining like terms. This X by itself, it's a 1X. And then 1X minus 0.35X would be 0.65X, because when you look at the coefficients, 1 minus 0.35 is 0.65. Now we got 0.65X where we want just plain old X, so divide both sides by 0.65. And if we do that on the calculator, hey calculator, what's 2.73 divided by 0.65? It shows up as 4.2. Now that's supposed to be a price of something. And we usually don't say the price of something is 4.2. We usually give 2 places after the decimal point. So it's like dollars and cents. So I would say the original price is 4.20 with a dollar sign in front of it. In other words, $4.20. And you can check that really does work. If you start with $4.20, subtract off 35% of that, that brings you down to $273. Okay, that seems like a good stopping place. I'm going to stop this video here. Then I'm going to come back and we'll look at a couple more examples of word problems.